This is a tutorial on trinomial factoring. When we factor a second degree trinomial with a leading coefficient that is not 1, well, this is basically just like multiplying two binomials, but in reverse. So if we had nx plus a times mx plus b, these are our two binomials, and when we multiply them together, we multiply everything in the first binomial by everything in the second. So we would take nx and multiply it by mx, and we would get mn x squared. Then we would take a and multiply it by mx, and we get ma x. Next we would take nx and multiply it by b, and we get nbx. And then lastly, we would take a and multiply it by b, and get ab. Now, if we simplify this, we'd end up with mn x squared plus nb plus ma times x plus ab. Now this may be easier to see with numbers. If I have 2x plus 1 and 4x plus 3, I would take 2x and multiply it by 4x and get 2 times 4, x squared. Then I would take 1 and multiply it by 4x, and I'd get 4 times 1 times x. I would take 2x and multiply it by 3, so I'd get 2 times 3 times x. And then lastly, I would take 1 times 3 and get 1 times 3. If we simplified this, we'd end up with 8x squared plus 10x plus 3. Now the idea of trinomial factoring is to take this and bring it back into this factored form. So if I wanted to factor 4x squared plus 9x plus 5, I would need two numbers, m and n, that would multiply together to get us 4. And I would also need two numbers, a and b, that would multiply together to get us 5. And I would also need a combination of those 4 numbers that'll get us 9. And the way to figure this out is first to figure out all the possible numbers that can be multiplied together to get us 4. Remember, we need two numbers, m and n, that multiply to get 4. Well, I can get 4 from 4 and 1. I can also get it from negative 4 and negative 1. I can get it from 2 and 2. And I can get it from negative 2 and negative 2. Well, now that I have all of those factors of 4, let's look at 5. I need two numbers, a and b, that'll multiply together to get 5. Well, I can get 5 from 1 and 5, or negative 1 and negative 5. So now I need a combination of these numbers, m and n, and a and b, that will get us 9. So we need to try different combinations of these numbers that'll multiply together and then add to get us 9. So I'm going to try 4 and 1 and 1 and 5. If I do that, I'll have 4 times 1 plus 1 times 5. Well, 4 times 1 is 4 and 1 times 5 is 5. I add those together and I get 9, which is exactly what I was looking for. So this means that our m is 4, our a is 1, our n is 1, and our b is 5. So now that we have that, we can just plug that into this form, and our factors would be 1x plus 1 and 4x plus 5. So this is my factored form of 4x squared plus 9x plus 5. And you can check your answer by FOILing this out. You would take 1x times 4x, which is 4x squared. You'd have 1x times 5, which is 5x. 1 times 4x, which is 4x. And then 1 times 5, which is 5. Add your like terms, and you'd have 4x squared plus 9x plus 5, which is exactly what we were looking for. Now, when you're factoring trinomials that do not have a leading coefficient of 1, there are some simple steps you can use to make finding your n and m and a and b simpler. First off, if your a is greater than 0, then always assume that the numbers that make up your leading coefficient, which are n and m, assume n and m are always positive. So if I have 12x squared plus 10x plus 2, then the factors of 12 that I would use would be 1 and 12, 2 and 6, and 3 and 4. I would not use any negative factors of 12. Another trick is if your c, or your constant term, is greater than 0, that means that it's a positive number. And since it's two numbers multiplied together, a and b, then the only way to get a positive number is to multiply either two positive numbers or two negative numbers. Now, which is it? Well, here I have positive 2. So, to get positive 2, the only way I can multiply that is to use two positive or two negative numbers. Now, if the coefficient of my linear term here is, in this case, 10, if this is positive, well, remember, those are the same numbers added together. So if this is positive, that means that I'm not going to use two negative numbers to get my 2. I'm going to use positive numbers. So I only need to consider positive numbers of my constant term. So the only ways I can get 2 with positive numbers is 1 and 2. Now that we've eliminated many of the possible factors of 12 and of 2, that makes finding the possible combinations that add together to be 10 a lot simpler. Now our last step is to try to find combinations of these two sets of numbers that will multiply together and then add to get 10. Well, we can try 1 and 1 and 12 and 2. If we do that, we'll have 1 times 1 plus 12 times 2. Now 1 times 1 is 1, plus 12 times 2 is 24, so this is 25, and that's not 10. So that combination doesn't work. Instead, we can try 1 times 2 and 12 times 1. If we do that, we'll have 1 times 2 plus 12 times 1. Well, 1 times 2 is 2 and 12 times 1 is 12. If we add those together, that's equal to 14. So that doesn't work either, because again, we're looking for 10. Instead, let's try 2 times 2 plus 6 times 1. If we do that, we'll have 2 times 2 plus 6 times 1. Well, 2 times 2 is 4, and 6 times 1 is 6, and that's equal to 10, which is what we were looking for. So that means that 2 is our n, 2 is our b, and 6 is our m, and a is 1. So if we plug that back into this form, we would have 2x plus 1 and 6x plus 2. So this is the factored form of 12x squared plus 10x plus 2. Now here we can try this again. We have 2x squared minus 11x plus 5. Now again, our leading coefficient a is greater than 0. So we're only going to assume that we're going to use positive factors of our leading coefficient. We're not going to use any negative factors. So the only way I can get 2 is to multiply 2 times 1. Now our constant term again is greater than 0, and the only way I can get a positive constant term is to multiply either two positive numbers or two negative numbers. Now I look at my linear coefficient It's negative 11. So if I'm going to add these same two numbers and come up with a negative number, that means that I'm only going to use negative factors of 5 because I want them to add together to be negative 11. So negative factors of 5, well, that's just negative 1 and negative 5. So I need to find a combination of these numbers that will get me negative 11. Well, that's pretty easy. I'm going to use 2 and negative 5, and I'm going to add that to 1 and negative 1. If we do that, we'll have 2 times negative 5 plus 1 times negative 1. Well, 2 times negative 5 is negative 10, and we add that to 1 times negative 1, which is negative 1. That's equal to negative 11, which is exactly what I was looking for. So that means from this form that our 2 is n, our b is negative 5, our m is 1, and our a is negative 1. So if we use those and plug that back in to this factored form, we would end up with 2x plus negative 1 and 1x minus 5. So our factored form then is 2x plus negative 1 times x minus 5.